go ahead and so here we are. So as you can see, today is 4:54. So let's take a look at that. So let's go to content. And so today, you know, in the last couple of weeks, I've been introducing the concept of Scapy and sniffing and spoofing. So we've gone through security axioms. Security axioms and sniffing, right? And then you had a homework, I believe. This is due on the 27th, right? So the sniffing lab. So then today we're going to look at the other half of that, which is spoofing. So I'll go over this this idea of now, you know, and initially we were just looking at scanning network data to obtain information about the packets, right? And now we are going to look at creating attacks in a sense as we are moving into attacks. So that's usually falls under the idea of spoofing. So we will go over this, so as you can see, just a few things in the folder. There's a few. This module will be like the previous one, where you have spoofing problems for C, C++, spoofing problems for Python Scapy. Python, as you know, is extensively being used nowadays for networking issues. So there will be a lot of there will be some other libraries that we will explore in the future beyond Scapy for a few other networking things. But let's kind of conclude this one. So with this idea of spoof, right? So now, as I said, C, C++, I just do because remember, all of these tools are usually built on top of the libpcap library, so it kind of makes sense to have a sense of how it works. And then here we have, as I said, we're going to do both in C++ and in Python. So let's take a look now. This, I think, is the new one, spoofing new. Just double check on the seed labs. I know you guys are always checking that. So make sure to see if they've updated something. But I do believe it's the latest one there. And so let's actually click on this, right? And you can see here. So in this case, we're going to focus on spoofing tasks. So let's kind of take a look at that, right? So I've talked about some of this, just a code example. So I'm not going to repeat all of this, given that this is actually the same document from last week. And instead, I'm just going to focus on some of the ideas. So I will demo today kind of what I expect from the spoofing lab. I'll start with the Python version of it, and then I'll do the C++, and then you should be able to solve it. But remember, the problems in question are Traceroute, right? I want you to work on that. And then one that I really like to see is the sniff and then spoof. So the echo request, echo reply. So getting a message back when you ping a non-existing machine, okay? And sorry, I have a cold, so I apologize if I'm sniffing a lot. All right, so we're sniffing. All right, so that's kind of the idea, as you know. So let's just go ahead and get started with the virtual machine. I'm gonna switch on over. You can just read through this document, but let's just start up the virtual machine. And before I get started, actually, are there any questions? I guess I should have asked. All right, so it doesn't seem like there's any questions. All right, so let's go ahead then and start up the view. Okay. All right, so I'm going to share the screen. I had planned today to also demo GNS3. GNS3 is a network simulator, and just was having some issues with the VirtualBox, but hopefully I will have that resolved by Thursday. So let's go ahead here. So I'm sharing the screen. All right, great. So as I've said many times, what we're looking at is network security, which basically network security. If you remember the views that I described during the axioms lecture, there's multiple views about security, right? So we can basically look at an attack from just the point of view of one machine versus looking at an attack from the point of view of a system of machines, basically a network. So in network security, there is the sense of individual computers and, sniffing and spoofing, attacks and defense. But there's also, if you look at the system, there's the component of the topology, right? The topology. So if you remember at the beginning of the semester, I gave you this topology, which is the topology that I usually like to always think about. So some of the issues that we're going to talk about later will revolve a little bit more on the topology itself. But for this lab currently, the only thing that relates to topology really will be the traceroute problem. So it's similar to the Ph.D. Moore case, right? So that one was also a trace routing kind of an issue, or TTL. And so in today's lab, we will also have this component of traceroute. So my plan today is really, I'm just going to go over, I'm going to read the problem and what we want to do. And then I won't solve the entire thing, but I will give you hopefully enough guidance so that, you can figure out the rest. Okay. So that's kind of the plan. And it should be a fun, as I've said many times, this class doesn't really, need a lot of lecturing. It's more about like doing things because you guys already know everything about the network and stuff. So it's really just about the different scenarios and the libraries themselves. So the best way to do this is just with problems. So I'm going to go ahead here and navigate to 454. All right. So I'm going to start with the Python one, and then we'll get to the C one, but it should be pretty straightforward. All right, so we are doing spoofing with Python. As I said, that kind of relates to the idea of attacks in a sense, right? A spoof packet is a packet that has been modified, right? It has been modified and probably shouldn't be there because it wasn't generated automatically. All right, so we're going to have our computer network. Now, one of the things we want to do in the first problem, is ping a non-existing machine, right? So I'm going to do this. So the sniff and spoof. So actually, in the past, if I used to do this lab with 1.1.1. But, and you'll see this in the PDF, I think, in one of the PDFs, it still says 1.1.1. But when I do that, actually nowadays, I get replies. So what I want to stress this, that you need to change in any documentation where it says 1.1.1, just change it to one, at least last semester, this would not return pings. Yeah, there you go. So you can ping 1.2.3.4, and basically the machine does not exist in the system, okay? So what we want to do then is we want to create, with the knowledge that we had from last week, a sniffing system. And you've already tried some of this in the Ph.D. more, right? So you got a packet and then you sent it back out. So we're going to do something similar, but this time we have to consider that we have echo request, which is the ping that goes out, and echo reply. So we want to generate the echo reply. Again, for this kind of problem, architecture is not at all important, or topology, sorry. So, we just need a couple of terminals and that should work. All right, so we've addressed that. So the IP address does not work because it's not real, right, when it gets pinged. Now, another thing that in these labs is pretty important is to have Wireshark running in the background, okay? So I'm gonna just go ahead. And I would recommend some of the problems will start to get a little bit harder, and Wireshark will be your friend to get something going. Okay, so all right, and here, right in the, should be listening, I think. And of course, there it is. So now, this is important. I'm going to stop it for a second. All right. So we've got our Wireshark output. We will be, since we're spoofing in a sense, or sending out packets, Wireshark will be very helpful sometimes to kind of troubleshoot like a debugger, because if we mess up some the source IP, destination IP, the protocol, etc., Wireshark will be able to give us the information that we need. So if you look here, for instance, I sent out several packets from 10.02.15, my VM, all the way out to 1.2.3.4. It is an ICMP packet over here. It is an echo request, right? And we would need to get back an echo reply as part of the problem. Now, things that, to look at, there's got sequence numbers, TTLs, and so on. Okay, so Wireshark certainly should be useful to have in the background. All right, so just leave it open, basically, and just use it there. All right, so now, we've looked at ICMP. Now let's take a look at how we can code sending out a spoof packet from the VM. Right, so let's go ahead and try that. So I'm gonna just do Python here, and of course Python. All right. So from Scapy .all import all. Okay, brought in that library. I'm going to create a packet. IP. All right, and then I'm going to just specify destination. So in this case, I want to get, so I was sending out packets. I was sending out packets from 10 something, I forgot the IP, to the destination 1, 2, 3, 4, but I want to change that. So destination then, it's going to be 10.0.0. I thought it was 16. 16. Let's do that. All right, and for the source, it's going to be 1.2.3.4. Okay. And also, of course, as we have learned, these are ICMP packets. So we just use the ICMP header. Okay. And now we're going to piece together a packet P. Oops, P. And it's going to be A/B. So that's the headers for the packet. There it is. And now I'm going to send it out into the network. So I'm going to send key. If it works. And the permission. Great. Forgot. So it's going to be A B, and then oh yeah. So it is from Scapy dot all import all. All right, and then a IP. All right, and now that a not EST for destination 10.0.0. What was this? 15 actually. 15. B is, see how Wireshark is useful, right? So I was able to there use it. So in a lot of the labs, I do recommend that you use Wireshark. Okay, and then now we're going to use do the next header. So that's going to be ICMP. And then now we can piece it together. Okay, and now send it back out into the network. Did I miss something? All right, so I'm getting a question that in Python you can, this is just a Python interpreter. It allows me to try different commands really quickly. You can, of course, write any Python code that you want in a Python script. All right, so that's send. And I sent out one packet, right? So hopefully then in Wireshark, I'm going to take a look at what I have in there. You see it? So the reason why I do this is that sometimes in these labs, Wireshark will be a lot of help to you to be able to demonstrate that you've accomplished a task, all right? So for instance, you can see here, we sent out to 1, 2, 3, 4 before, right? It was an echo request. Now we go down here. Where was it? Yeah, that. And we can see the packet went from the source 1, 2, 3, 4. It's an ICMP, but it's an echo request, right? So we will have, it's still an echo request. So, we'll need to think about that one, right? But that's kind of a simple demonstration of sending out the packet and capturing it in your Wireshark environment. Now, since I sent out that packet as an echo request, I should have gotten an echo reply. Don't you guys think that I should have gotten an echo reply? So what might I be missing if I didn't get that echo reply? Because I see the packet here, but there should have been an echo reply sent from my machine, correct? You guys think so?
Does the echo reply come from the ICMP protocol? Is that like built in, or?
Oh yeah, where I'm literally pinging 10.0.0.15. That's my VM. So I sent out a packet here as a ping request. I can see that it's here, right? You know, from 1234 to 10.0.0.15. So 10.0, oh, wait a minute. It's 10.0.2.15. Okay, all right, sorry, I missed that then. So let's modify it. So it should be as easy as changing this one, right? You guys agree? Are you with me on what I'm trying to do?
Yeah.
Okay, good. All right, so then now I'm gonna do send P. All right, I sent the packet. So now I go to Wireshark. All right. Again, 1, 2, 3, 4. Oh, maybe I wasn't. Let me try it one more time. Okay, I sent the packet. There's 3 packets here, but this one is not going to 10.0. Source, destination. The packet. There are 4 now, so it's capturing these, but it's not replying. Huh. Let me actually check that. Terminal here. Yeah, 10.0.2.15. That's the...
Maybe try changing your Wireshark interface to any.
Okay, yeah, okay. Let's do that. I'm just gonna start this thing. All right, so I'm gonna try any here. CMP. Just gonna ping something. Okay. All right, those are the packets. This one over here. See, it's got this packet 10, 1, 2, 3, 4, 10, 0, 0, 15. The packet is going to the actual VM, right? So it should have replied, I think.
Still showing the destination as 10.0.0.15 rather than 10.0.2.15.
That's true.
So it's not gonna reply because that IP address isn't live.
Yeah, that's true. Why is it? Because I changed it, right? Didn't I? You know what? I've only been changing A, but I never changed P. You see that? I never changed this, and I'm actually sending out P. Okay, yeah, good eye. All right, let's try that.
Yep, they're both there now.
Work, right? Yeah, good catch. Thanks, Dakota. Appreciate it. All right, so yeah, so you can see here 1, 2, 3, 4. Yeah, so my error was I was changing A. I forgot that packet is made of A. So, and I was sending out packet P. So great, we're back on track. So 1, 2, 3, 4. That's I'm sending that to 10.0.2.15, and then 10.0.2.15 is replying back to 1, 2, 3, 4. Great. So we've got that settled. So we can ping the machine. Now that we've accomplished that, you know, we have a way of spoofing packets and sending them out. Another thing that you can do is, so all right, so now for the, so since we're talking about 1.2.3.4, we are going to do the sniffing and then spoofing exercise. Okay, so the idea basically is to create a little, you know, I don't know what we call it, but you know, a spoof script. So let's go back here. I'm gonna exit out of here now, and I'm just gonna create a script instead. So I'm gonna call it spoof ICMP. That'd be fine. All right, so the basic logic here would be that we need to capture some packets. So let's do from scapy.all import all, and then we're gonna do sniff packet sniff we're going to need a filter because we don't want to capture everything, right? So you guys will have to think of a filter. I will leave that blank for you to figure out. But the idea is to, you're pinging 1, 2, 3, 4, and it doesn't exist, but you're going to provide echo replies, basically. Okay, so now, All right, so now if we think about the structure of this packet, we can have here our PRN function, which is going to be spoof packet, PKT. And we're going to define spoof PKT 1, 2, 3, 4. Okay, and so now a couple of things you might want to look at as you. So let's just start with this. So print the packet itself, PKT, and then you're going to specify for this that you want the IP header dot source. Okay, so just to see that it works, let's kind of over here. Obviously, it's ICMP packets, so I'm going to do ICMP, right? And that should do it. So now I'm going to run it. So Python 3, and then it's sudo Python 3. All right, sniffing there. I'm going to go to the other terminal here. I'm going to ping 1.2.3.4. Obviously, there's nothing there in the network. If we look at Wireshark, there it goes. If we look at the other one, it should be. One was given.
You never passed it PKT.
Ah, that's right. PKT. All right, so now should work. All right. And again, it's, oh, there we go. And as you can see, it's working now. And that's a basic idea, right? So we have the sniffer. From 10.0.2.15, I'm pinging 1, 2, 3, 4. 1, 2, 3, 4 does not exist, but the sniffer is capturing it. So now the question is, we need to craft the echo reply. So I'm going to go ahead and kill this one. Go back to the other one. Just notice how it stopped. It's pretty good. So now we can go back to the script and just keep structuring this one. So other things that you can print if you'd like, you can print like the packet PKT IP dot destination. You can just show everything. I'm just going to leave it commented out, but you can, PKT dot show and look at more data if you think you need it. And then now the question is, we need to craft a packet that goes back out. So here you have a couple of options. One would be to copy the original packet and just change. So something like P equal PKT, right? And then of course, you're going to go in there and do P IP, for instance, P IP, or you call it P new, something like that. And then dot src would be equal to PKT IP dot no, destination, right? So we got to flip them. P IP dot destination PKT IP dot src. And then, okay, we're going to need to have a send over here. And then we're going to send out P. So let's see what happens when we do this. There. All right, that's running in the background. Let's start the pinging over here. 1, 2, 3. Still no reply. So we're not getting a reply. Let's look at the code here. And you can see now this, but we really can't tell much of what's going on. So let's go to Wireshark. Now in Wireshark, what do we see? We are sending 10.0.215, 1, 2, 3, 4, but we are not seeing the 1, 2, 3, 4s in return, correct? So those are not going out. So why are those not going out? Stop this. Go back to the script here. All right, another approach that I'm going to take then, since that didn't work, is I'm going to just create a new packet from scratch. So I'm going to say A equal IP. And then the source of this one will be PKT, IP, right? And then so PKT IP dot destination. So the same idea of flipping them, comma, then I'm going to do destination DST, PKT IP dot source SRC, comma, and then let's just leave it at there for now, but there may be some additional parameters that we need. Okay, that's the whole point of this actually, is just figuring out which parameters you should. That's why I was just trying to copy, because that way with copy, I don't have to figure out too many parameters. Now they're going to do the B, the ICMP header. ICMP header. And that's going to be let's just leave it there for now. And without any fields. I really just want to see a packet in Wireshark. That's all. So now I'm going to do new PKT A B for now. Let's not add anything else. I know you guys noticed something last week that should be in a packet, but we'll get to that. So then now it should be just sending this one. I flipped the IPs, so now we should see a packet as if it's coming from 1, 2, 3, 4 in Wireshark at least, right? Right, guys? Do you see any issues? All right, so let me try this one more time. Okay, I'm running it. I'm gonna go to Wireshark over here. No, this. I'm gonna do the ping, so it's going. Now in Wireshark. Ah, there we go. Excuse me, I'm sorry. All right, so you can see here, now at least I've succeeded because they're inverted, right? So that the 10.0.215 is sending out the packets to 1, 2, 3, 4. And now we are also seeing packets from 1, 2, 3, 4 in reply. Does this make sense, guys? Make sense?
Yes.
Okay, perfect. So now the question though is, of course, this is not enough because what I want is for you to fake this, and 1, 2, 3, 4 is still not responding with the appropriate information. So what do you guys think we're missing? So now comes the question, because it's the central question in attacks in network security that are related to packets. The essential question is, what information needs to be in that packet that you're spoofing, the one that you're attacking? So you literally have to be familiar with the headers and with all the values that belong there, okay? So now I'm gonna kill this and I'm gonna go back to the script, and now we can have a discussion. Let me do that. So now we can have a discussion of some of your ideas on what should be in this packet. So what do you think? What are some suggestions that you think might be missing here? So what are some suggestions?
Maybe adding some type of acknowledgement message.
Acknowledgement, yeah, like syntax, you mean, like the acknowledgement flags? Yeah. So in the case
Yeah.
of packets, you usually need to send something back. And you need definitely the data type, the type that we are sending. So one thing we might look at is just Wireshark itself. So let's take, see if we can find any ideas. All right, so if I look over here, there is this, in Wireshark at least, it's kind of making some suggestions here. So echo reply and echo request. So that's a difference because reply, the terminal is making the echo request, right? Not the reply. So then maybe something to do there. Now there's also this thing ID over here. Sequence, right? Sequence number, etc. So how do we approach this one then? Now, one thing is just to kind of copy those values from the original package. So for instance, let's see here in the ICMP header, we can say, all right, there was something about ID, right? So ID equal the ID of the original one. So that would be PKT. Now that should be in the ICMP header. So then we're going to say ICMP like that. And then dot ID. So we're copying the ID from the original one, right, into this new one. The sequence was also mentioned there. Now we will have some sequence attacks next week. So sequence numbers are pretty important. So here we're going to do the same, PKT, ICMP, dot sequence. You see that? And so that's kind of the approach that we can take. So we can try this one out one more time. So let's run it. Right, there we go. So it's sniffing, but nothing's happening. We have to trigger the ping. There it is. We go to Wireshark. I can see that they're definitely going out. Now let's take a look at them. Now they have, right? They have the same ID, the sequence numbers. They're corresponding, so that's a good thing. Now echo request and echo reply. Let's see here. So 1, 2, 3, 4. 10.0.2.1.2.3, okay. So what do you guys think? Yeah. Let's see. Your IPs are switching. Mine are the same. Not sure why. Okay. They should be switching, right? That's the whole point of the code. Is the thing is I haven't gotten this to work yet. I'm not getting any echo replies here. They should be switching because remember the packet that is sniff is going to 1, 2, 3, 4. The reply packet should be coming from 1, 2, 3, 4. So what you do is here in the header of the spoof packet, the source should be the destination of the original packet. And the destination of the spoof packet should be the source of the original packet. That's why they should switch. So it's still not working, right? So that hopefully that means we just need to add more fields, right? So what are some other fields that you might recommend? What do you guys think? We've got an IP header, we've got a ICMP header, and we've got TCP. No, this is an ICMP packet. So ICMP packets do not have a TCP header. So what about, you know, what I believe some the code I noticed this last week that the packets needed to have and what was it, Dakota? Do you remember?
There's like some kind of payload. So just like some kind of text.
Some kind of text, right? Remember you saw that. So let's do payload over here. And I'm gonna do payload should be what? Let's just copy the original payload, right? So how would we copy the original payload? We go to PKT and then we call it raw. Yeah, like that. All right, so let's add that in as payload over here. And now we've got a little bit more. So once again, so this is the process. I mean, you know, obviously if you can copy one packet to the other, that's also useful. I guess I was pinging already, but still no luck. The ping. Now, why is this important? This is important because, and actually let's look at this one here. You can see they're still flipping, so that's good. What's important here, and if we click on one of these, you can remember you can break out the headers here, ICMP. This should be the payload of whatever is being sent there. The idea with this family of attacks, it's what I'm trying to get across is that this is a new family of attacks that exploits the vulnerabilities in networking protocols. Okay, so for instance, here, we're just relying on how ICMP works to try to trick it, right? We're going to try to trick ICMP based on how it works into believing that a machine replied, because that's just the protocol. So we just have to understand what the protocol is looking for, and then we can, we just have to understand what the protocol is looking for, and then we exploit that. Okay, that's the family of attacks that we are exploring here. So let's try another one. Let's try, go back to the script over here. No, not here. Sorry. Here. Why is this one still running? Maybe there's just packets there or something. All right, so somebody's asking me, all right, show me your code then, Andrew, because I don't know what your problem is. Can you bring it up? I just enabled it. And everyone just look at it, see if you can spot something. So you have ICMP, spoof packet, source and destination, create a IP source is packet IP destination. Destination is packet IP source. And you say they're not switching. Is it running? Is this thing capturing? Okay.
He's only getting replies.
Yeah, you only get.
You need to switch your Ethernet adapter to any, like somebody brought up earlier.
Yeah. The same issue I had at the beginning.
No, it's the Wireshark interface. You have to switch.
Wireshark. Don't mess with the VM. I think I just closed it and started it all over again. It was just click on Wireshark again. Oh,
If you just close Wireshark, it's easier to select a thing.
any. Put the filter on there.
Are the sequence numbers supposed to be increasing, or are they, like on mine, they're all seemingly random?
Yeah. So for now, we're just copying it basically right now. We're not incrementing it. Yeah, sure. So let's take a look at the later on in other problems. Definitely when you have a TCP connection and you're exchanging data, definitely the sequence numbers have to be incremented. And that's a problem that we will have later when we do the TCP IP attacks, but that's a much harder problem. Okay, so for this one, should be more straightforward of just copying the fields. So let's go ahead and so still no reply. Let's go to the other script, which is running. And now let's see what other fields we can explore here. So there's one field in particular called the type. So I'm going to do type. And let's try 0. So this should be the echo request, echo reply values. So, and actually, you know what, since we're doing this, let's just do pkt.show as well. And I'm gonna uncomment these. All right, so I added the type. All right, let's go ahead now and run it. Okay, all right, there we go. So now you can see in the ICMP, the type is the echo request, echo reply information that I was talking about. There's a sequence number there. You can see that the ID, there's the raw, and then the IP over here, there's these fields, right? So there's, well, we have already addressed source destination, but, you know, TTL, all those, you know. So let's take a look at, okay. What do you guys see?
It's getting
It worked, right? Exactly. So that's it. That's, you know, this is how it works. And that, you know, would you say we've accomplished the objective? Does this make sense, guys?
Yes.
As you can see, we have exploited, as I said, a protocol, networking protocol, in this case, ICMP, into believing that a machine that does not exist in the network actually does exist. So notice how obviously this is an attack because that this should not happen in a sense, right? But by knowing how to craft packets, how to spoof packets, and knowing really well the protocols, etc., you can perform this family of attacks. All right, great. So are there any questions before we move on? All right, so somebody is asking me to show the code one more time. All right, sure. Let me kill this. Actually, let me stop the ICMP also. There it is. So I'll leave it up for some time for you guys to look at. Right. All right, great. So are there any, so this concludes that problem. So for the ICMP spoofing lab, you will have to do this one. So I wanted to demo this one, given that I kind of wanted to give you an idea of what to expect. And a lot of the problems are very much like this, okay? Very much like this. So now the other problem that we have to tackle is, let's see. So we did the sniff and spoof of a missing packet. Now this one, I'll admit, is a little bit more difficult, but I will let you guys work on that one. And that's really ultimately really your homework for this lab assignment will be this next problem. So just double check that I got this. Yeah, all right, great. So that's the one. So let's go back now to read the problem that you have to work on. Now here you will bring together what you did with the H.D. Moore lab last week, and then this exercise that we did today. So I'm going to do Control X, clear. Now we're going to switch over. Just make sure everything's off here. Clear. All right, so let's go back to white space. Here we go. And click on bright space. All right, so we haven't done the C problems yet. I'll do those in a sec. And then spoofing with Python and Scapy. From the, so this is, what we're doing. So from the two attached PDFs, the old and the new one, complete the problems related to spoofing packets using Python and Scapy as described in the previous videos or PDF. This includes generating spoof packets, repeating the ICMP echo request to 111 problem, but this time with Scapy. So that's just 1, 2, 3, 4, and the Traceroute. So, so really just two problems because just spoofing, that we already did that. So now because this copied from last year, I'm just going to delete this. And then I'll create a new one for this year. And then for the C, as you will see, you basically just have to do the 1.2.3.4, what we just did in Scapy, but in C. You can see here from the two attached PDFs, the old and new one, complete the problems related to spoofing using C++. Now, very important here, I just used the mem copy code, this one. Now, I have three files here, sniffx spoof 1 and sniffx spoof 2, and then mem copy. They're all basically the same one. It's just that mem copy is probably the easiest one, and these just are a little bit harder. So it's up to you if you want to do it with any one of these, but certainly with mem copy, you should be able to solve it easily. The other ones are just more for your own information. So use the mem copy code attached on Brightspace. In particular, solve the problems related to sending an ICMP echo request to a non-existent IP such as 1.1.2.3.4. All right, so this one is also from last year. Just gonna delete it. All right. Okay, so you have then the 3C files, and then this is, I believe this sniffing and spoofing is the description for the C. Yeah, so this is just for the C one, but it's basically the same thing. Just read through this. And then here the problem is literally what we just did with it, but in C. Okay, so I'll just describe the code a little bit in a sec. All right, but let's now focus again on the Python one. So the Python one, really, there's only two problems. One of them we just did, the sniff and spoof, and then the other problem I want you to tackle is it's gonna be, now here's some information, by the way, on the fields in the headers, so definitely read it. Oh, here it is, the traceroute. So traceroute, yeah. So really the two problems basically from this lab are this one, and then also this one, but we just did that one. Okay, so you're already done. So there's only two problems. Okay, 1 and 2. Is this clear, guys? That this is all you have to do for the spoofing Python version? Just two problems?
All clear.
All clear, perfect. We'll get confused. All right, great. All right, and we've done one of them already. The easy, we did the easier one. Now this one is a little bit. Now, this traceroute problem, you can probably solve in several ways. So I will mostly just read through it right now, and then I might provide a basic set of hints, but I don't really want to solve this one. I want you guys to solve it. All right. So traceroute, right? So we, you know what it is, of course. So the objective of this task all right, traceroute. So the objective of this task is to use Scapy to estimate the distance in terms of number of routers between your VM and a selected destination. This is basically what is implemented by the Traceroute tool. In this task, we will write our own tool, right? So basically it's like you're writing your own traceroute, okay? This idea is quite straightforward. You send a packet, any type, to the destination with its time to live TTL field set to 1 first. This packet will be dropped by the first router, which will send us an ICMP error message telling us that the time to live has exceeded. That is how we get the IP address of the first router. Do you guys understand that? Makes sense? Because traceroute, you have to put in the routers, right? So that gives you the router IDs. That is how we get the IP address of the first router. We then increase our TTL field to 2, send out another packet, and get the IP address of the second router. We will repeat this procedure until our packet finally reaches the destination. It should be noted that this experiment only gets an estimated result because in theory, not all these packets take the same route. But in practice, they may within a short period of time. The code in the following shows one round of the procedure. So I'll go through this, but basically you can see we create an IP packet. We specify a destination that you want to set, a TTL, right, as described in the basically this paragraph gives you the algorithm to follow. Then put in an ICMP header, put it together and send it out. If you are an experienced Python programmer, which you guys are, you can write your tool to perform the entire procedure automatically. And this is what I want you guys to do, right? So I want to see, I don't want you to do this manually. So I've seen this in some students like to do this manually and then just like write it down. But no, you have to, try to do automatically. So you guys are not new to Python, and so you should not do it manually. Yeah, and don't do this, please. So don't like do it automatically. So for our, because you guys are advanced, you should do it automatically. And that's it, right? So that's the description of the traceroute problem. Are there any questions on this one, guys? You understood the basic algorithm, correct? All right, perfect. So no questions. So you understand that's your assignment. So let me, before I, so let's go to Brightspace and let's just create it so that there are no issues. Contents. All right, so under spoofing, you got the 2 PDFs for your reference. I'm going to add a new assignment here. And I'm going to say homework, spoofing in Python. Okay. And this will be due on the 3rd at 10 p.m. You'll stay open until the 5th. Using Python and Scapy, complete the following 2 problems. Okay, so problem 1, sniff and spoof to a sniff and spoof, let's say. Ping a non-existing IP, such as 1.2.3.4, and get replies via, right? That's pretty much what we did. 2, read the Traceroute problem from the PDF and complete it. And completed. Is this clear enough, guys? What we have to do, that traceroute is task 1.3 and the other one is 1.4. Yes, all right, great. So it's clear. So I'll just add, okay, good. So I'm just gonna say that it's 1.3, just so that it's obvious. Task 1.3. Yeah, all right. All right, so it seems like it was clear for everyone. So I'm just gonna add that one. All right, and that's those are the problems. Let me see. Here, I'll just do a short demo, I guess, of the traceroute idea, just a little bit, but without giving you too much. Let's go to the virtual machine then. All right, so that's the virtual machine. So then, traceroute. So as we saw in the code, let's see. So traceroute, traceroute, I think the VMs already have it. So traceroute looks like that. So basically, what I want you to do in the lab is I want you to first traceroute something. Whatever your scenario is, traceroute it, give me the output that you get, and then do it with your script, and then that way I can also I can compare your real traceroute to your traceroute done in Python. So let's do 1.2.3.4. Right, and you can see here, this is kind of how it should go. Let's try and, and then obviously let's try another one. Okay, so you'll have to find a way to get the traceroute information in there. I'm going to try PM1. Maybe it needs to be in bridge mode or something. I think maybe if I try it with my physical machine. Okay. So the command prompt on my computer does not have.
I did it in bridged mode and it was fine.
It works in bridge mode.
Yes.
Yeah. So. Probably network operations manager or something.
I did machine settings and then network.
Okay. Okay. Network. And then bridged. See if that works. Oh, there we go. Thanks, Ryan. So as you can see in bridge mode, yeah, it works a little bit better. And then this provides, basically the routers that you're going to be using, etc. So now you have to do this behavior, basically, but with your own Python script. Okay. So now, here, Now, the idea is, so once you've established that trace route, also look at Wireshark. That's always a good one. So I don't know if we were running this, but you might want to have your Wireshark there to help you out. And then, as the example basically said, you're going to change the TTLs, okay? So let's see. Okay, so we have to, let's see, we have to, let's see if we can't do this with Wireshark. So let's do, I'm just gonna do like a couple of these and let's see what happens. So A, IP, and then, oops, sorry. Sudo Python 3. There we go. All right, so, and then I need to import, so from Scapy .all import all. Right, now I'm going to create a packet IP like that. A is gonna be, now I'm gonna use that destination DST. So the Google server, which is the one I used before. And then now a.ttl, actually add the source. And then, just so that we can find it really quick. And then as the PDF indicated, a.ttl equal 1. So you'll be changing these, right? You'll be changing these. So in Wireshark right now, it's pretty much stopped. Okay, so now I'm gonna do TTL1, and then I'm gonna create the packet itself, and then send AB. Right, sent one. I'm gonna change the TTL to 2. Wait, sorry, I have to hit enter. And then, yeah, just send. So I'm gonna send it, change it to 3. Send. All right, so I sent 3 packets. Let's look at Wireshark. Okay. So from one, oh, well, this is not gonna work, I guess. Because the reply needs to come back to you, correct? Guys? So what do we need to change here? Think about it. So if we read the PDF here, it says, this packet will be dropped by the first router, which will send us an ICMP error message telling us that the time to live has exceeded. That is how we get the IP address of the first router. We then increase our TTL field to 2. So what IP do you think we need to have to get that back? What do you guys think? What would you try next? We're in bridge mode currently, right? So I'm just going to check the IP here. now I am, what's my IP? I think it's this one, right? 10.0.0.64. 10.0.0.64. So then. Right? And then I'm going to send this out. You guys think it worked? What do you guys think? You guys hear me?
Yes.
Yes, right? Yeah. All right, perfect. All right, so I think, so if you get what happened here, then you totally can solve this now, I think, in my opinion. Right, should be pretty straightforward. So just write the code to do the trace route problem. All right, all right. Are there any questions on this one before we move on to the next topic? Right, doesn't sound like there's any questions. So let's move on then to the right space environment. All right, and now we're gonna switch gears to the C++. I'm gonna close this one, and I'm gonna look at this document. So the older one, still pretty good. Right. So in this one, if you remember last week, so you guys should be seeing the PDF here. So we did everything up to 1.5. Now we just need to do this one, right? So spoofing. As we know, when a normal user sends out a packet, operating systems usually do not allow the user to set all the fields in the protocol header, such as TCP, UDP, and IP. OSs will set most of these fields while only allowing users to set a few fields, such as the destination IP address. However, if the user has the root privilege, she can arbitrarily change these values, as we have seen extensively so far. And this is called packet spoofing. And it can be done with raw sockets. So that's something that you will see in the C code, the use of creating the socket and everything. So raw sockets give programmers the absolute control over the power packet construction, allowing programmers to construct any arbitrary packet, including setting the header fields and the payload. Using raw sockets is quite straightforward. It involves 4 steps. And really, if you think about it, Python is, an interface to C++. So even though we're doing this in Scapy, pretty much in the background, Scapy is using code like this, the compiled versions of raw sockets with the PCAP library. So using raw sockets is quite straightforward. It involves 4 steps. Create a raw socket, set the socket option, construct the packet itself, and then send out a packet through the raw socket. And then, you guys can read that tutorial on the PCAP library. Now, here I've made this problem a lot simpler, so you won't really have to write any code. It is based on that sniffx code that you were already familiar with. So, but I'll show you the mem copy version is actually pretty much simplified for you. So just answer the first two questions. Please use your own words to describe the sequence of library calls that are essential for packet spoofing. This is meant to be a summary. That's, you don't have to do anything, just write the sequence of steps. Then the why do you need to root privilege? You should know that. So really the problem is exactly the 1, 2, 3, 4 problem we did before. Please combine your sniffing and spoofing programs to implement a sniff and then spoof program. This program monitors its local network. Whenever it sees an ICMP echo request packet, it spoofs an ICMP echo reply. And you know what happens next. So really, you just have to do this, but with the C code that I have provided here. So let's take a look at that. As I said, you can read all 3 files. That's not a problem. But really, I think the simplest one is memcopy sniffx. So I'm going to download this file. And now let me open it with just, let me open it with Notepad++. So I'm going to have to share that. Okay, so you should now be seeing the memcopy file. Okay, this is the one that I posted on there. So as you can see, it's very much the same sniffx code that we talked about last week. But really what I'm going to point out is the things of interest. So as you can see here, this is the main, and it's the same issues as before. As the main. So obviously this is the filter. You'll have to change it just like you did before. The number of packets, you may need to change that. Something to think about. And then you have down here the PCAP loop, right, where it's got making a reference to got packet, right, where it captures the packets. And so now we go to got packet over here. You can see that's the function. You can see that the packet is being sent over here. Okay. And so we talked about the headers already. Remember, we got Ethernet, IP, TCP, and payload headers. And so what's different this time around is this switch. So in this switch last time around, it just printed out things. But now if you notice, what type of packet are we targeting? We're targeting ICMP packets. So notice that whenever now, when you get a ICMP packet, notice that function, send ICMP reply. So this is the function that will handle spoofing the packets. Notice that you're also including the packet in there. So we go to send ICMP reply over here. And this is a new function that was not there in the original sniffx, but you can see send ICMP reply just grabs the packet itself, basically. And then if you notice here, you basically send out buff, right? And with all the protocols, etc., all of this is already preset to create the socket options. So really what's happening here is that this is all for the connection. But if you notice, you have this line here, okay, where you basically create, you get packet, but you create buff. And buff, basically, when you do B0, you kind of initialize it. And then notice this command, memcopy, basically will copy the contents of packet, the original sniff packet, into buff. Now the spoof packet, the version that you're going to send out. And then after that, once you have that, then you can tie the headers to buff, right? And then you can see that is being done here with a pointer. And then now you can wrap the the headers like IP header, etc. Set some parameters. And notice here that you just change a few values like type, checksum, etc. But these are already hard coded for you. I've already pretty much I took care of that. Notice type 0 is just like we did it in Scapy. Notice over here that we are switching IP header from IP source to IP destination. So notice we're just flipping it, right? And we created a temp one to assign that to IP source. So basically this code does the same as Scapy. It flips the IPs, it initializes the values, and for the most part, it just copies the original and then it just sends it out. So this should be easy. The code pretty much works out of the box, and you just have to run it, and hopefully you'll get the same result as you did with the Scapy version. Now, in this code, something very interesting may happen. In your pings, in your ping replies, you might get in parentheses something that says DUP, and that's dupe. It stands for duplicate. Now, in your assignment, when you show me the screenshot of the pings that are echo replies, right, from 1, 2, 3, 4, you need to get rid of those dupes, okay? Because if I see the dupes, what's the problem with that? Like if I'm pinging a non-existing machine, but then I see these dupes, I'm gonna think, something fishy is going on here, right? That's not what, so you need to get rid of those dupes, but I'm not gonna tell you how to do it. So you have to, think about it a little bit. Does that make sense, guys?
Yes.
Perfect. All right, so that's it. That's your spoofing. We are done with spoofing lab. So we'll do something else on Thursday, unless you have questions. But we have concluded this topic. So I'm just going to go to Brightspace to kind of summarize. Yeah, so these three are for spoofing. Then the sniffing. I'll add the homework assignment for spoofing with C on Thursday. Okay, but that concludes that module. Okay, so that concludes this module. All right, any questions? Are there any questions? All right, I'm not seeing any questions. Great, so I'll stay for a couple of minutes if you have any questions. Otherwise, we'll stop here for today. So I'm going to go ahead and stop the recording now.